Hello friends, welcome again. Quality of materials and quality of finished road are important to have a road that will live its design life without requirement of major maintenance. And there are different forms of quality control that must be exercised during construction of a road. In earlier two sessions, we have discussed control of alignment, level and surface regularity in part 1, and in part 2 we have discussed the quality control test required for granular layers like sub-base and base coats. In this session we will discuss quality control tests which are required while laying bituminous layers of a road. The purpose of quality control during construction is to ensure that all materials and finished product are as per design or contract document, and road construction specifications and estimates provide basis for effective quality control. And for this purpose, these two guidelines are available. Ministry of Road Transport and Highway Specifications for Roads and Bridge Works 2013 and Ministry of Rural Development Specifications for Rural Roads 2014 for low volume roads. And these two documents have been widely referred in this session. There are different types of bituminous works which are adopted at site, starting with prime coat, tack coat and fog spray, seal coat and surface dressing, premix carpet, bituminous macadam, dense bituminous macadam, bituminous concrete, slurry seal and microsurfacing, and stone matrix asphalt. And there are some common tests which are required for each of these layers. The general types of tests which are conducted in bituminous works are quality of binder, quality of aggregates, requirement of gradation, binder content, temperature of binder and aggregate during mixing, quality of the mix, that is the stability, density, flow, etc., and density and thickness of finished layer. We will now discuss the quality control test requires for each type of bituminous work separately. First is prime coat, tack coat and fog spray. Prime coat and tack coat are applied before laying the layer of a bituminous course. When bituminous layer is provided over a granular surface of base course, then prime coat is mandatory. And when the existing surface is bituminous surface, tack coat is normally sufficient. The material for tack coat and prime coat is of low viscosity cationic emulsion of SS type as per IS 888-7 for prime coat and RS1 for tack coat, or it may be as per contract document. The type of test which are conducted on materials is the quality of binder. This is as per IS 888-7 and frequency of test as suggested in MoRTH 2013 is as suggested in the IS code, whereas MoRD says one test per lot or per 10 ton. Now this suggestion in IRC code is given here in this table. It says depending upon the number of containers in the lot, you take the number of containers for testing of the quality. The binder temperature should be tested regularly, and rate of spread of binder, that is 3 tests per day or 1 set per 500 meters square, but not less than 2 tests per day as per MoRD 2014. Now this test is conducted to determine whether the spread of binder is adequate or not. And to conduct this test,
take 3 aluminum or other light metal plate of 200 mm by 200 mm and by 20 mm depth. Take the weight of these plates accurately up to first place of decimal, and then these plates are placed along road in wheel path at an interval of 10 meter before spray. Now allow the distributor to move for 50 meter covering all the 3 plates. Now these plates are wrapped in polythene bag and they are taken to the laboratory, and then their weight is taken up to first place of decimal. Now similarly, transverse distribution is noted by placing 3 plates at an interval of 50 cm in the path of binder spraying equipment, that is in lateral direction. Then we make calculations like this, that area of the plate 0.2 meter by 0.2 meter, that is 0.04 meter square. And let us say initial weight of the tray was A, while the final weight of the tray is B, and therefore increase in weight of the plate is B minus A, and that is the spray on the plate.
Then rate of spray can be calculated using this equation, that is increase in the weight of the plate divided by area of the plate. So B minus A upon area is 0.04, that is 25 into B minus A. The next type of bituminous construction is seal coat and surface dressing. Seal coat can be either a liquid seal coat or pre-mixed seal coat when fine aggregates are also used. Similarly, surface dressing can be provided either in a single layer or in two coats as per contract document. Here you need to exercise control on the quality of the binder and aggregate. And the frequency of test as prescribed in MoRTH 2013 and in MoRTH 2014 are given here. The quality of binder as suggested in the IS code, and this table I am reproducing here, that depending upon the number of containers in the lot, you take the sample for testing of the material. Whereas in case of MoRTH 2014, it says one test per lot or per 10 ton of the material. Test on aggregates like impact value or loss engine abrasion value, flakiness index in case of MoRTH, and combined index for flakiness and elongation, one test per 100 meter cube, and also with the change of source. Stripping value and water absorption test should be conducted, one for each source. Grading of aggregate, 2 tests per day, and or 1 per 100 meter cube or 1 test per day. Binder temperature should be checked regularly, and rate of spread of material, 3 tests per day or 1 per 1000 meters square, but not less than 2 tests per day. The procedure for determining rate of spread of material is given in Manual for Construction and Supervision of Bituminous Roads. IRC SP20 also suggests a performa for determining the rate of spread of aggregate in surface dressing, and the approximate rate of application of binder and aggregate as suggested in MoRTH 2013 is given here, depending upon the nominal size of aggregate, that is depending upon the thickness of the surface dressing course, the quantity of the binder and aggregate should be as per this table. The next layer is pre-mix carpet, and the construction of pre-mix carpet is similar to surface dressing, and therefore the quality control parameters are same as described for surface dressing. All these tests are same, their frequency and their type are same as for surface dressing. Now here the binder content and thickness are added. Binder content should be determined 2 tests per day or 1 test per 500 meter cube or at least 1 per day. And thickness of the layer should be checked regularly, but there is no such requirement given in MoRTH 2013 for the thickness. The requirement of aggregate for pre-mix carpet are given here. Impact value should be maximum 30%, flakiness index 30%, water absorption not more than 1%, and coating test at least 95% area should be coated. And when crushed gravels are used, not less than 90% of the crushed material retained on 4.75 mm sieve shall have at least 2 fractured faces. The next type of bituminous layer is the bituminous macadam, BM. And test and their frequency are same as for pre-mixed carpet, with the following difference: that the flakiness index in case of MoRTH specifications or flakiness elongation index combined in case of MoRTH specification should be at the rate of 1 test per 350 meter cube for each source and 1 test per 250 meter cube for each source. Binder content 2 tests per day. Thickness should be checked regularly, and density of compacted layer should be taken at least 1 per 700 meter square of the area. In MoRTH specification, it is 1 test per 1000 meter square area. Now, a density of the compacted layer must be determined by core cutting method, and The physical properties of aggregate which are suggested in MoRTH specifications are given in this table. They must be ensured at site. In case of rural roads, MoRTH specifications suggest that the combined in place of combined flakiness and elongation indices, only flakiness index to be checked, and it should be 25%. And similarly, this retained tensile strength test is not specified in MoRTH specifications. The binder content and density of the BM layer should be compared with job mix formula, and the binder content should be within a tolerance of 0.3% by weight of total mix from the job mix formula when individual samples are taken. The density of the layer should be as per contract document or as per job mix formula. The acceptance criteria for test on density is based on statistical analysis of the data. The mean value of a number of tests should not be less than a specified value that is given in the contract or in job mix formula plus 1.65 minus 1.65 upon square root of n into standard deviation. Here n is the number of samples, number of tests taken, and standard deviation is calculated from the value of the field test data. Now it is so because some values will be lower and some will be higher than the density corresponding to job mix formula, and therefore the statistical method is suggested for arriving at the acceptance criteria. I will explain this equation with the help of one example. How do we use this equation in field to arrive at the accepted density? Suppose the density as per job mix formula or as per rate contract document is 2.27 gram per centimeter cube for a BM layer. And when you conduct test in the field, you take 10 samples, 10 cores, and determine density of these 10 cores, and you get these values. Now some of these values are more than 2.27 and some are less than 2.27 with a mean value of 2.284 and standard deviation of 0.011. Now we apply that equation that the mean value is not less than a specified value plus 1.65 minus 1.65 upon square root of n is 10 here, into standard deviation, that is 0.011. Specified value is 2.27 and this comes out to be 2.283, and mean value should not be less than this value. So mean value is 2.284, that is the average of these 10 values, and therefore the construction is accepted. The next layer is DBM and bituminous concrete, the most frequently used layers in a flexible pavement on highways, and these layers are not recommended in MoRTH specifications. The quality of binder as suggested in IS code, and here the quality of the type of material should be tested as per IS 73 or IRC SP 53 in case of modified binders, or IS 15462. Test on aggregate, impact value, loss angle separation value, and combined flakiness elongation index, that is one test per 350 meter is cube and with a change of source. Soundness tests and equivalent value, PI value, water absorption value, polystone value, one test per source. Stability and wires analysis of the mix, 3 tests for each 400 ton of the mix. Moisture susceptibility of the mix, 1 test for each mix type. Binder temperature for application regularly, and binder content 1 for each 400 ton of mix, and density of the compacted layer 1 per 700 meter square area. Now as I told you, these layers are not recommended for low volume roads, and therefore they are not included in MoRTH specifications. Here also you can see that type of tests are similar to what we discussed in the case of BM, with addition of few tests. The physical requirement of aggregate for DBM are given in this table, and this we have discussed in another video also on dense bituminous macadam. And similar table is suggested in MoRTH 2013 for bituminous concrete layer also. The binder content should be again within a tolerance of plus minus 0.3% by weight of total mix from job mix formula when individual samples are taken, and density of the layer as per job mix formula, but acceptance criteria remains same. That when you take mean of 3-4 values, then the mean should not be less than the specified value plus 1.65 minus 1.65 upon square root of n into standard deviation. When you take the sample of the mixture for the grading, the permissible variation on individual sieve size should not be larger than this. That is, for aggregate passing 19 millimeter sieve or larger, it should not be more than plus minus 8% variation from job mix formula. And similarly, this permissible variation from job mix formula is given for different sieve sizes. Binder content should not vary more than plus minus 0.3% from job mix formula, and mixing temperature should be within a range of plus minus 10 degrees centigrade depending upon the type of the binder. Slurry seal and microsurfacing, they are thin bituminous surfacing layers which are used for preventive or renewal treatment of the surface. The type of test which are prescribed here, again the quality of the emulsion, one test per lot of 20 ton or as per IS 8887. And I would say here that these layers, slurry seal and microsurfacing, are also not recommended in MoRTH 2014, and they are only available in MoRTH 2013. The quality of aggregate like sand equivalent value, water absorption and soundness, one test per source. Water absorption should normally be less than 2%, but if it is more than 2% but less than 4%, it may be permitted in slurry seal if aggregate passes the soundness test. The aggregate moisture and aggregate gradation should be tested at the rate of 2 tests per day at site. The calibration of machine once per project. Now, calibration of machine here means the flow of all constituents as per job mix formula. And for that matter, 2 kg sample of the mix is taken and verified for proportioning and mix consistency. The complete procedure for calibration of the machine is given in IRC SP 81. Binder content should be determined at the rate of 2 tests per lane per kilometer. Aggregate gradation, when done at site, the percent passing at individual sieve should be within the tolerance of these values. Passing 4.75 millimeter, 2.36 millimeter, 1.18 or 0.6 millimeter, it should be within a range of plus minus 5% from the value given in the contract document. Aggregate passing 0.3 millimeter plus minus 4, passing 150 micron plus minus 3, passing 75 micron plus minus 2%. And lastly, the stone matrix asphalt. SMA is also used as a wearing course on heavy traffic roads, and this is also a mixture of aggregate and bitumen, and therefore all tests that are prescribed for bituminous concrete or DBM, they are done in case of stone matrix asphalt also. The quality of binder should be checked and the number of samples per lot should be as per IS or IRC code. In SMA, generally we use modified binders, but IS 73 suggests the number of samples to be taken depending upon the lot size. Up to a lot size of 50, you take 3 containers randomly for testing. And if it is 150 to 151 to 500, you select 7 containers for testing. The guidelines given in IS 15462 and IRC SP 53 for modified binders are slightly different. For a lot size of up to 50, you take 2, and for a lot size of 500 and above, you take 10. The quality of aggregate, same routine test like impact, abrasion, strafe test or percentage of fractured faces, they are to be conducted at site as per this frequency. And all other tests are recommended 1 test per source. The mix grading should be checked at the rate of 1 test per 400 ton of mix produced, or at least 2 tests per day per plant. And similarly, the volumetric parameters like air wires, VMA, or theoretical density GMM, they should be tested at the rate of 3 tests per day. The moisture susceptibility of mix should be determined at the rate of 1 test for each mix whenever there is a change in quality or source of aggregate. The test for binder content and density, the frequency is same as given in case of bituminous concrete, that binder content should be 1 set per 400 ton of mix and density of compacted layer 1 per 250 meter square area. Acceptance criteria for density in case of SMA is same, that is based on statistical method as we described in the case of bituminous macadam, bituminous concrete or DBM layer. So friends, thank you very much for watching this video. If you have any suggestion, you can write in the comment box.